All right. So to go further with this idea that the ocean has boundaries and hence you end up creating gyres or circulating systems even though winds are just blowing either from east to west or west to east. The subtropical gyres obviously happen in the subtropical regions. Now you can begin to again put down the concepts you have learned. You have learned about the subtropical high, which was related to the sinking in the Hadley cell. The Hadley cell had trade winds in the tropical regions and subtropical regions and meeting the westerlies in the mid-latitude regions. So the gyres are basically these large circular loops of moving water. Subtropical gyres are centered right around the subtropical high that we talked about. And the boundary of the gyre, as we can see here, you have westward tropical currents, you have eastward currents to the end of the subtropics, you have southward eastern boundary current and a northward western boundary currents, right? Already you should begin to remember your Coriolis here. Okay, why? Because the currents that are moving westward here in the lower latitudes are experiencing lesser Coriolis because Coriolis at is zero at the equator, begins to increase towards higher latitudes and reaches maximum at the poles. So lower latitudes have lower Coriolis effect, so the rightward tilt or the northward push of the water as it's trying to move west is less than the push it will feel southward as it's moving eastward in the northern part of the subtropical gyre. More water is being pushed to the south because the Coriolis is stronger at higher latitudes than the amount of water being pushed to the north at lower latitudes because Coriolis is weaker. We already took Coriolis, wind forcing, ocean boundaries and ocean currents, and we are adding it together to create a more complex concept now. Subtropical gyre, but variation of Coriolis along the latitude is going to matter. Okay, so subtropical gyres are bounded by equatorial current, western boundary currents, northern and southern boundary currents depending on whether you are in the northern hemisphere or southern hemisphere, and eastern boundary currents. Okay, so the five subtropical gyres are of course in the North Atlantic, South Atlantic, North Pacific and South Pacific. Indian Ocean, as we have already seen, has a very different configuration because of the monsoon circulation, so it doesn't have a well-defined subtropical gyre in the northern hemisphere, so it only has a subtropical gyre in the southern hemisphere. These names mentioned in the book, they are not used by anybody, so you shouldn't even bother to remember them. Okay, so we will look at these currents in detail in the next podcast, but you can already begin to see when you put together your concept of the winds with the ocean currents, with their boundaries and their gyres, things begin to look a little bit complicated, and I'll show an animation to see that actual flow is even much more complicated because, as you can imagine, in such a big ocean, it's not like there is a ribbon of current. As the water is going along, it's circulating locally in waves are coming by, there are eddies and swirling motions, and Coriolis is acting along the way, and so on and so forth. But when you average data like that drogue data we got for currents, or the Argo float data, or the pressure gradient derived currents, and so on, if you average them on a long time, then obviously there are mean currents. So things drift along the mean currents, and we'll see the examples of things that drift in the ocean and produce information about the currents. So I'm going to stop this here, but we will look at this map in great detail in the next podcast so that you can remember the circulation as well as the names of the currents. Most mostly based on their directions, but also some other names that come because of their characteristics, because of their history, and so on.